Welcome to a new video in my home automation series, and today I want to talk about another Node-RED project which has only started just a few days ago, but I think it's coming along already quite well. But I also want to get your opinions on if I'm on the right track and if I should really add something to it, because this is about irrigation control, and obviously this is not really a time to work on irrigation control because, well, winter is coming, so next time I want to irrigate is probably going to be next April or May. But I want to be prepared because I think besides working on some logic and some Node-RED flow, how I'm going to control it, probably I also need some hardware in order to make a good working system. And the purpose of this new functionality or this new Node-RED flow or the logic is to figure out if I need to irrigate my lawn. And I want to decide that based on how much water the lawn needs, and it needs to be calculated based on the outside temperature and also the amount of rain in the last couple of days or in the past period. And what I have done so far is just a basic concept. As you can see, I have a bit of flow which creates some logic, and it does all the calculation, and then at the end it just sends the trigger whether I need to irrigate the next day or I don't need to irrigate the next day. And also I've created some dashboard as well, so I can see the data. It's mostly just to visualize the data because obviously I am just doing the calculation and everything, so I need to figure out if I'm on the right track and the calculation is working correctly. And it also has some logging as well, so I can actually see what was happening inside. And the logic I'm following is based on what my gardener and the guy who installed the irrigation system told me. First of all is that I should only irrigate the garden when it's the lowest temperature of the day, so like just before dawn, just to make sure that the most amount of rain is used, or the most amount of water is used for irrigation, and not to evaporate in higher temperatures, which would just result water loss or create additional humidity, which could result in infections or fungi growth or something else which we don't want. And that's easy to do because I can time my irrigation to start, let's say, like 5 in the morning or 6 in the morning. The other thing is that I was told is that it is better if I keep to a strict irrigation logic, like a fixed logic, which, let's say, I'm going to irrigate this zone for 50 minutes and the other zone for 15 minutes. So keep that constant and rather vary how many days I irrigate in a week. And that should follow how much water is used by the lawn, which again is based on the temperature of the day. So obviously that controls, that determines the evaporation of the water and also the growth. And of course, if it was raining, then, the rain provides the water instead of the irrigation. And I actually found this article, which is in Hungarian, but I'm going to show you here anyway. I mean, I'm going to put the link in the video description so you can just do a Google Translate. But it has this chart which says if the daily maximum temperature is this much, so if it's above 35 degrees or 30 to 30 degrees, 25 to 30, this is how many millimeters of rain or water the lawn needs in order to grow properly. And also, if you irrigate your water and then your irrigation is going to sprinkle like 8 or 9 millimeters of water, which you can easily measure with a dish that you place on the water, and you run your irrigation and you just measure the depth of the water. That's basically how many millimeters of rain equivalent water you irrigate. Then this is how many times you need to irrigate your lawn. So about 35 every single day, or maybe if it's even higher, then multiple times a day. And if it's between 30 and 35, then 5 or 6 times a day, 4 times a day, 3 times a week, 4 times a week, 3 times a week, and 2 times a week. So this is the logic I wanted to implement. And when we had like really hot summers this year, then I usually just turn on the irrigation to run every single day. And I noticed that it kept the grass green and all the flowers green, and everyone was happy. So I assume that my irrigation probably delivers these 8 or 9 millimeters or thereabouts. So based on this observation and the fact that above 35 degrees I was irrigating every single day, I'm going to follow this guide to determine the logic of my irrigation. So what I want to do is to measure or record what was the maximum temperature of the day. Based on that, I'm going to determine what is the water needed for that particular day, which is going to be in millimeters. Obviously, if I had rain on that day, I'm going to add that additional rain to this sort of like water balance. If at the end of the day, based on the temperature, I'm going to subtract this one. And then obviously, if that balance reaches 0, I need to irrigate. If that balance is positive, then I don't need to irrigate, because then I still have sufficient water in the ground, so I can just leave the irrigation for next week. And then of course, if I irrigate, then I'm going to add that 8 millimeters to this balance. So it's just, added to the balance because I delivered water using the irrigation system. I hope it makes sense. I don't think it's very difficult, but you just have to get used to this concept. So before I show the flow, I wanted to show you the UI as well. So here I just show all the value that I collect and measure. So there is a current temperature, which is coming from an outside temperature sensor, and there is a max temperature, which the flow calculates as the maximum temperature of the day. And yes, this is the 11th of October, and we had like 29 degrees. Well, it wasn't really 29 degrees. I think it was more about 25 degrees. And that actually goes back to what I mentioned in the previous, in the beginning of the video, is that by this I realized that I need a temperature sensor that I can reliably measure ambient temperature, because this particular temperature sensor is outside on the clear, because that's the one which also measures the rainfall. So obviously it needs to be outside to measure rainfall, but most probably I would need a separate temperature sensor that I can put somewhere in the shade, so it actually measures the real temperature, because it was definitely not 29 degrees, it was 25, which is still good for middle of October, but yeah, so I need to take care of that. So probably I need to build another sensor over the winter time. And then I measured the rainfall. Again, I decided that I'm going to use an actual rain gauge. So I have this really old weather station that I purchased from Maplin, and it's a 433 megahertz station that I can receive from RF Link. I made a separate video on that. So this is actual rainfall, which is measured in my garden, and I decided to use an actual rainfall meter because especially in the summer where we have storms, sometimes I just get a small amount of rain here where I live, but the other side of the city could be flooding. So I don't want to rely on weather forecast, because I feel that sometimes these storms, especially the summer storms, are so localized that if you use an internet forecast, then it's just not going to be accurate enough. And based on the temperature and based on that graph that based on this one that I've shown, the system calculated that for today the lawn would need 4 millimeters of rain, and I have 30 millimeters of balance at the moment. So these 30 millimeters would be, I was just testing, but this would be the case if there was like a big rain in the last few days. So the rain would obviously add to the balance, and then this balance would get slowly reduced based on the temperature and the water need for every single day. So you can see that this is the water balance. So let's say there was a big rain, so the balance is up, and then it's slowly reducing now as the days go by, and effectively the plants just use water from the ground. And I added a data count as well. I just wanted to have this just to make sure that I have data coming into the system, because some of the logic can work of this one. So if you are not getting any rain data or temperature data, then the system can send you a notification saying that, well, I'm trying to run the calculation, but I don't really have any data. So this is just like, a plus function. I also added this chance of rain, which is coming from a weather forecast. So I'm using Open Weather Map to get weather forecast for my area, and it has a chance of rain or percentage of precipitation field, and I get this value for the following day. So I thought that maybe what I can do in this logic is that look at this value, and if this value for the next day is, let's say, very high, so there is a very big likelihood that it's going to rain the following day, then I'm going to skip the irrigation. So it's like more like sort of preventative. So if I know that it's going to rain, then I'm just not going to irrigate it. I just wait for the rain tomorrow. I mean, worst case, it's not going to rain tomorrow, so I will just run the irrigation the following day. And I set the current temperature. So some of these values get locked here. So let's assume that this was a big rain. So as I said, the balance is up. That's the outside temperature, just for reference. And this is the water needed. So maybe there was a small amount of rain here, which added to the balance, and then there was no other rain. And here you can also see that I run the irrigation, then it adds that 8 millimeters to the balance. So you can see 816, well, this was actually not rain, but I was just testing something. And then at the end of the day, when it runs the calculation, it says that I calculated the new water balance, I added 1.8 millimeters for rainfall, but on that day, actually 2 millimeters needed for the plants, so that's -2. So you can see that here, well, there's a bit of a rounding error, which I fixed. So the difference of this is minus 0.2. So from 32, it has gone down to 31.8. And of course, that would just keep, doing it every single day. If this reaches 0, then it's just going to say that, oh, watering is needed. And then it will trigger the watering system. So that's the sort of the concept and how it works at the moment. And the flow is the following. It's actually this much. Yeah, I mean, most of it is just display stuff. So everything is implemented in this big irrigation computer function node, and I try to keep everything self-contained here. So everything which is a parameter is stored outside, so hopefully you won't have to come here to make changes, which is not entirely true. I'm going to come back to that a little bit later. First, we have a settings. Oh yeah, and everything is stored just like with all my other code, is stored in the context. And here I store it in the node context. So there is a settings, which comes from here. So this is where you can configure your program settings. And by the way, everything is also explained here in this comment node. So the settings, I'm just going to show you here. So it is a JSON, and it has this temperatures object, and then it has a couple of items. So that's basically an array. So this is where you configure what is the water need above a certain temperature. So what I have done is I basically implemented this table here, and that's the temperature, and this is the water needed. So if the temperature is over 35 degrees, I need 8 millimeters. If it's over 30 degrees, I need 6 millimeters. If it's above 25 degrees, I need 4 millimeters. And at the moment, the temperature, well, the max temperature was 29, so it's still below 30, so I only needed 4 millimeters of rain. So you can make it less granular, more granular, you can change the values, you can put whatever values here, you just have to make sure that whatever temperature you put in here is in the same unit what the temperature comes in the next node. So it can be Fahrenheit, and you put 95 or 102 or whatever. And this chance of rain delay is this one here. So if, let's say, the chance of rain is more than 70%, then the irrigation is going to get delayed, even if irrigation would be needed. And the max messages is the number of messages that the system keeps. Obviously, if it reaches 50, it would just drop the last one or the oldest one. So that's the settings that you can configure here, and then you send in using the settings topic. You need also data which sends in the temperature, and then it needs to be in the temperature topic, and in the payload you just send in a value. That's all it cares about. So for me, it is coming from my 433 megahertz weather station. And you also need a rainfall, which has a topic rainfall, and it also comes, well, it comes from my weather station, but through a calculation. And in this payload.today, it always calculates the rainfall for today. I think probably this is the one which needs to be tweaked a little bit, because at the moment, so this calculation always resets at midnight. So at midnight, the today would reset to 0, and then it start calculating the rainfall for today. So I usually run the irrigation at 6 a.m., but because I'm calculating the rainfall from midnight to midnight, this logic runs at 11 o'clock. So it can take, the today's rainfall into account, which means that at 11 o'clock, it will decide whether we need to run the irrigation 6 a.m., so in 6 hours time or 7 hours time or 5 hours, whatever. So it's going to basically just lose what is going to happen between 11 and 6 o'clock. So ideally, I think what I should really do is to run the calculation at like half an hour before the irrigation is about to start, so it can take the whole thing, all the waterfall into account. But then I would need to change how that logic works, how my calculation works, which I would probably do, but I haven't done it yet. And that would be the reason to change the main logic in the main flow. And by the way, you send in the, going back to the temperature, you just send in the actual temperature, and the code will keep track of the maximum temperature. You can also do the same with the chance of rain, and that's coming from Open Weather Map. So the daily one is tomorrow, POP is the percentage of precipitation, and then times 100, so it comes as a percentage. And finally, there is an input for irrigation. So that's sort of like a feedback loop. So once the irrigation is completed, then it's just going to add that 8 millimeters to the balance. So, and it comes in the irrigation topic. So this is all the input, and based on this, this function node is going to do all the calculation, and it's just going to put everything in here. So you will see the max temp, the rainfall, all the counts and everything, and that's what is piped here into this calculation node. Oh, okay. Ooh, I need to do something. Why is it coming as a text? Okay, I need to fix that. And yeah, so it does all the calculation, it keeps track of the messages, the current temperature, chance of rain, everything. And then finally, what happens, it also keeps this thing here, the statuses. And then every time a data comes in, all this information is piped out on the first port, so that goes into all the displays and the graphs and everything. And so that basically feeds all the UI that I just usually watch as sort of like a debug of the code. And if irrigation is needed, then this data is also sent out on the second port. So this is where I said, we need to do something in the watering. So, and I mean, there are so many different solutions how you can solve this. You can, have outputs, and then you can just, start a pump and open the valves. Or maybe what you can also do, if you already have an irrigation system where everything is programmed like a Rainbird or a Hunter, what I would probably do is that these systems usually have an input to an external rain sensor, which is usually like a small cylindrical thing. And I believe the way it works is that it has a cork inside, and whenever it rains, that cork gets wet and it expands, and inside it, switches a switch. And that basically just inhibitor for the irrigation system to start. So with the reverse logic, I think you can do the same here. So let's say your irrigation computer is programmed to irrigate every single morning, but then based on the node-RED flow, you can operate a small relay. And if you don't want irrigation, you use the rain gauge input to short it, so basically block the irrigation. And if you want irrigation, you just open it and let the irrigation run. And And I have this delay which feeds back the, once the irrigation is completed, it adds the actual water amount to the calculation. So it knows that the extra water has been irrigated and, delivered to your lawn. And that's it. That's where I am at the moment. It seems to be working fine based on all of these. Oh, sorry, and I forgot to mention, probably the most important one, is that this is the calculate logic. So that runs 3:11 p.m. every day for me. But again, it would probably make more sense to run it like half an hour or maybe 10 minutes before the irrigation is due to start. Yeah, you just have to have this inject node with a calculate topic, and that runs the irrigation, that runs the calculation which will eventually include these messages in the log. And also during this, you can have additional messages, like the temperature reading count is low, or the rain reading count is low, or the chance of rain is high and the irrigation is delayed, or watering is needed and starting irrigation. So those are the additional messages that you might get when this calculation runs. I think I managed to cover everything which is mentioned in this article and just sort of like implement this thought process and the logic. And I'm guessing I have all the data for that. And the real question is not so much if I have all the input data, but whether that input data is correct and it's coming from a proper source. As I said, like external temperature sensor is really measuring the outside temperature and it's not being shined on, and it's measuring higher temperature. And also if you can have a proper water gauge instead of relying on a web service, which I find much less reliable, because that's the only way to truly know how much rain, the amount of rain that you get in at any point. So I think that's it. So if you have any ideas, any sort of thoughts, just leave them in the comment section below. I'm probably just going to tweak the code a little bit. I just need to find out why the balance is coming as a number, because obviously the calculation is not going to work based on this one. And then I can release the flow as well. But as I said, if you are living in the Northern Hemisphere, we have a couple of months to get this, really dialed in, and then get this implemented by the time the next summer season comes, like in 6 months' time. So I think that will be all for today. Thanks for watching, and hopefully see you in the next video.